Okay, great. Hi, everyone.
Satvinder sir, just excuse me. I'll just introduce you formally
Sure,
and then we
you
will
do
begin.
that. Yeah,
Okay, yeah.
Thank you.
So, very, very good afternoon. I'm very, very happy and excited to start the session today. Just for a knowledge and information to everybody. Satvinder sir, we have started the guest lecture series for our, School of Scholars children. The motto of this is let them have insight hours and in which they can learn from masters. So I'm very happy and excited to welcome you because this is the first session that we are beginning for this session. And today we have opened our schools. The beginning will be very great. And as far as maths is concerned, can I request everybody to please keep yourself on mute so we can interact properly. So, dear friends, teachers, principals, we have a very, very passionate mathematician with us, Mr. Satvinder Singh, and the topic is quadratic equation. I would like to, briefly introduce sir. He has dedicated his career to inspire and spread love for math in students across the globe like UK, Argentina, India, and Myanmar. His teaching journey has been an enriched experience for everyone. Somebody's mic is on. Swati ma'am, please see if you can unmute. I think Vaishnavi Thakre. Please follow discipline. Online sessions will not be. Yeah, thank you so much. So he has his career devoted to the mathematics and he has been, enriched by using a method which is investigation, inquiry, and engaging technology to create interactive learning environment. And I feel this technology, I think help, the math best to make the interactive session, to learn best, to visualize very, very abstract concept. So he's passionate about this. His passion also lies in building strong mathematical thinkers through STEM education. So, sir, really, we are glad and honored to have you today. I think quadratic equation is very abstract, very, very abstract, and they learn in the school. But I think this is something which has number of applications in our daily lives.
Yeah, true.
I'll not
Yes,
take
thank
much of
you.
your time. The all floors is yours, sir.
Yeah,
Please.
thank you so much for this kind invitation. I'm feeling like motivated here in front of more than
I'm
400,
sorry,
500
just a
students.
moment. I'm sorry about this. I request all schools to have your videos on. I request all schools to have your videos on. We would love to look at your faces, children's faces.
Yeah, and then sir, Satvinder sir also said he's going to pause. So feel free to interact, ask your questions, raise your queries. So this session will be fruitful if it is interactive. Again, I request all of you to keep your videos on. Sir.
Thank you so much. And as I was saying, definitely it's like a great privilege for me to be a part of this whole School of Scholars guest sessions. And it's a first session today. And I'm very excited to interact with our students here. And so hello, students, everybody. I hope you have enjoyed your break and you're actually ready to start the new term. And today, I will spend these 45 minutes time with me actually about quadratic equations. So as ma'am already gave a brief introduction. So if you have any question during the session, do let your teachers know so that they can type in the chat and I can respond. And if you want to know more something about any other thing, so do let me know during this class or at the end also, I will take some questions. And yeah, so without wasting more time, let's continue. And my aim for today is about using some softwares. Of course, as ma'am already said, that maths is the way we learn in classroom is very abstract, very problem solving techniques. But sometimes when we visualize things, when we picturize mathematics, then it makes more sense to us. And we always like, it's a complaint from parents and students. Oh, where we are going to apply this mathematics? Where should we apply this? I haven't seen mathematics anywhere in my real world. So that's the best opportunity for you to take one topic from your whole curriculum and see how and where you can apply quadratic equations in your real life. So just to let students know and teachers know, I'm going to use two softwares, which one of them is called GeoGebra, and it has a 2-dimensional and 3-dimensional view as well. So second one is the Desmos. So I hope you will like this session and you will have some better understanding about quadratics after attending this session. And thank you for all the participants here. So let me just start with the starting task. So I hope you all can see my screen. And if there is anything you feel that, no, we are not able to see, do let me know. So I want to start this session with the basketball. So I'm gonna call all the ballers and aspiring all-stars. Think you can sink a perfect three-pointer. I hope many of you are aware about the basketball game, right? So today we'll try to explore the science and maths behind the shooting of a basketball to score a 3-point or maybe more. So yeah, I hope you're ready with that. And I hope this will definitely make some relation with you and the sports, with the bridge, which is called mathematics. Yeah. So I hope you guys are ready to swish. Yeah. Yeah. Good. So let's begin. Here you go. So I know students may not be able to respond, but I'll just try to showcase them something so that they can actually try and see. I'm going to play this video clip for 1 second. And I want if teachers can just type quickly whether it is going to hit the basket or not. And then we will explore the mathematics behind it. So I'm ready to play this video for 1 second. Ready? Yeah. So if I can see any response in the chat, I'll be very happy if it is going to hit the basket or not. Teachers can just talk or just take some information from students if they want. Otherwise, I'll just taking a pause so that students can think what is going to happen if I can continue this video and they can see that whether this basket is going to hit the basket or not. Yeah, so if that's fine, if because I know students may not be able to respond and I may not be able to receive responses immediately, but that's fine. I'll show them one more. Hopefully they can actually say yes. Oh, let's find out whether it is going to do or not. Yeah, thank you for that response. Okay, let me show you one more. This is shot 3. So try this now. And one more. So after looking at these 3 shots, I want students to think that how mathematics can help a player, or how we mathematicians or math people can understand that hitting a basketball can actually help us to learn mathematics and can give a real life application of mathematics. So I know the responses may be with the students, but I will reveal the answers now. So I have shown you 3 shots. Let me show you one more time. First one is this one. And most of the students said yes. Second one is this. Yeah, I hope I heard in the chat that it is also yes, but let's see the third one. Probably you will say yes or no. So don't worry. Let's find out whether it is going to hit the basket or not. So have a look. For the first one, because it was a different way of throwing it. So look, yes, you were right. It was ready there. It was going through the basket. Let's have a go for the second one, because second one with a different angle. Oh, yes, it did also. And I could see the answers. Yes. Thank you for responding. Have a go with the third one. I think most of you also said yes, but let's find out. Oh, look, it was not. So that basket could not hit the basket. Oh, sorry, the ball could not hit the basket because the position of the player, the force he applied on the ball, it actually led the ball to reach its height above the expected value, and it could not go to the basket. So I hope you can see some sort of shapes here. So I would like to call this shape. If anyone would like to type in the chat, that would be great. Otherwise, I'm going to just reveal. We call in mathematics these shapes as parabolas. So it's P-A-R-A-B-O-L-A, parabolas. So when it's like a U-shaped curve, and it has some association with mathematics. And let's find out that. So by just looking at these shapes, you will understand the mathematics involved in the shooting a basketball. So have a look. Look, can you see this mathematics equation? That was for the first ball. So let me just try to make my mathematics equation, which can actually continue the path of the ball. So have a go, have a go, have a look, look. So I can definitely see it. Yes, this particular quadratic equation is ready for the basketball to hit it, right? And if I don't keep these numbers correct, then I will not able to hit the basket. You can see here. So if my basket is going to follow this path, it will not go. Or if I just try to make it maybe more at the height value, then also it is not going to hit. So it depends on the pattern. So look, as soon as we follow the pattern of the ball, and it will continue. So guys, this is actually your very beautiful quadratic equation. And of course, while solving questions, you may not be able to see that how the curve is actually built, right? Because of the squares, because of X, and because of these numbers. I know these numbers are a little bit weird for you, but yes, if we can actually find out the math connection with the journey of the ball, whether it is going to hit or not, so we can actually relate. And it's not only one concept, you can definitely relate with other concepts. I'm just going to take a pause because I can see there are some chat messages. Yes, parabola. Yes, you're right. Yeah. Okay, so let's see the second one as well. Now, this was the first one. If you remember, the first one said yes. Let's see the second one. So I remember for the second one also, most of the students replied yes. So let's find out. So I'm adjusting the position of my shape, which is actually helping me to create this quadratic. And yes, it is going in the basket. And same thing, if I change any one of these numbers, negative 0.19 or 16.2, it may not hit the basket. Have a look. So this is another quadratic. This is another quadratic. So all these quadratics will not make our ball go to the basket. But when we select a correct quadratic for the motion of our ball, then it is definitely going to hit the basket. So you can see here. Look, so how it can actually travel from this position and enter in the basket. Let's see the third one. If you remember, third one could not. So have a look. And the reason is very clear here. You can see it, you can visualize it, you can picturize it, that why it was not able to hit. So look, if you try that, yeah, it is actually following the second part of the curve way before the basket. So therefore, this particular quadratic will not help us to hit the basket, not to score 3 points. So you see, this is the height on the y-axis. That's how you can visualize. The x-axis actually representing your position from the pole, from the basket, and the vertical axis represents the height. So as you actually use the timer, so you will see that ball may have started from this particular position and it will continue its journey through this curve. But if it is following this particular curve, negative 0.33, x minus 11.85, square plus 17.05, this is not going to help us to shoot the basket. So we have to make some changes in that. Look, what if the ball could go in this way? Then yes, we could definitely hit the basket. Maybe like this as well. This is also the possibility. Again, possibility here. Yes, look. So all these are possible quadratic equations or quadratic trajectories to hit the basket perfectly. And you will see this particular quadratic in many forms in your real life. It is just the one example I have taken. So now you can actually see or visualize that how understanding of quadratics will help you to hit the shooting or not. So now I have a question for you guys. If you see these equations, if you see 0.18 x minus 13.35 square plus 16.2, I would like to know what these numbers are actually meant for you. Can you relate these numbers with the picture given? I'll take a moment and will definitely wait for any response. So teachers, if you can collect some responses and type immediately, that would be helpful for me. My question is, what these numbers are, why these numbers are important for us. What if I change negative 0.18 into positive, or what if I change 13.35 to something else? How these numbers are playing an important role to hit the basket? That is my question. So if you are ready with that, I will definitely wait for any response in the chat box. So look, these are numbers, and all these things are actually on different quadratics, so different journeys. So by looking at these graphs, that which statements is always true, the graph always intersects the x-axis, or the graph always has a vertex, or the option D. I could not see the chats, but that's fine. I know because it's difficult to see. Okay, let me see. Is there any message here in the chat box? Yeah, parabola. Yeah. Oh, yeah, definitely. Yeah. So that's a good identification. Whosoever did it, thank you so much for sharing your input. So guys, let me just take a step back. This is what you know. A times x squared plus bx plus c is a standard quadratic equation. And we all know from a quadratic formula method, x can be calculated using this method, which we call quadratic formula or Sridhar-Charya formula, right? So it's like a b squared minus 4ac discriminant method. I hope you understand why I have mentioned that b squared minus 4ac is greater than equals to 0. And look, the shape is called parabola. There are actually points. One is here. I hope you can see on my screen. Second is here. These 2 points are called roots, the zeros of this polynomial or the roots for this quadratic equation. So imagine you have a quadratic equation and you solve with this method, right? You will have your 2 possible answers. One of them is going to be -2. Second one is going to be +1. Every parabola, every quadratic, no matter what A, what B, or what C is, all parabolas have their vertex. So vertex is actually sometimes it's in the minimum position. So right now, this is in the minimum position. Sometimes the parabola is like this. In that situation, this is the vertex, what we have seen in our previous examples. So this represents the maxima. So these are some characteristics of any quadratic equation. If you won't be able to understand it if you don't see the graph or if you don't picturize it. So have a look. So that I'm going to draw a line here in the middle. This line, the vertical line parallel to y-axis, is actually called axis of symmetry. So if you see, the graph is same on the left and same on the right through this line. So we call it axis of symmetry. This is called the vertex, the minima or the maxima point. These points are the roots, and you can easily determine by calculating this. But my question is, in your curriculum, you don't see your quadratic equations visually. You actually solve on a paper. You find out what the discriminant is and then decide whether that quadratic will have one root, two roots, or no real roots, right? So let me show you that as well. So have a look. Think for a moment. See this equation, x squared plus 6x plus 8 equals to 0. Think without solving, will it have two roots, one root, or no real root? I will wait for 10 seconds. If anyone can type answer, that no voice. Can someone confirm if I am audible to? Someone already responded that it is going to have two roots. So I don't know how did you figure it out, but it's a good thing you have calculated quickly b square minus 4ac, isn't it? So yeah, you definitely need some sort of calculations. But if I show you the graph, immediately you will understand why it has two roots. So this is actually the graph of x squared plus 6x plus 8. And yes, your x-axis -4. And you can see here both answers by two methods. And I'm sure that you have seen these two methods before. For those in class 9, they will definitely wanted to show you. If you can picturize the parabola x squared plus 6x plus 8, then you will see immediately, oh, is crossing my, it has two roots. You will see, look at this position, isn't it? Because so when the discriminant or parabola repeated roots or just particular that it is x plus 5 times x plus 5, or from quadratic formula, you can see the discriminant is actually 0. So by showing you these 2, 3